Hello everyone, today let's solve the problem geometric progression, right? So this was asked in the Codeforces round by division 2, right? So you can just go through the question. It's very easy to understand. I'll just summarize the question so that it will be easier for us to solve the problem, right? So just give me a second, 1 second. Yeah. So what the question states here, we are given an array A, right? So you'll come to know this one when I consider the input output. We are given an array A of size n and ratio k, right? Size n and ratio k. Array A of size n and ratio k, right? So this is fine. We have to count the subsequences j less than I and j, sorry, yeah, I less than j and this one j less than L basically. In the sense, I'll just write it in this way, right? I less than j, j less than L basically. So that A of j equals A of I into k. So that A of j, so we are going with the geometric progression, right? GP. So this one will be A of j equals A of I into k, right? So I'll just give me a second here. A of I into k. This is fine. And A of L equals A of j into k. And also A of L, so this is equivalent to A of j into k, right? So this one is A of j into k. This is fine. Now, what we need to do, we need means we have to go with the triples that need not be contagious, right? So we have to consider the triples that need not to be contagious. Only indices must be strictly increasing here, right? So the question states that we can go with the triples that need not to be contagious, but only integers must be strictly increasing. Just keep this in mind. Value can be negative or large, right? So k has to be greater than or equal to 1 in simple terms. So this is nothing but k, man. K has to be greater than or equal to 1, right? So values can be negative or large. K has to be greater than or equal to 1, and we have to output the total number of length 3 geometric progression. So what we need to output here, length 3 geometric progressions. So this is very important, man, right? So we have to output the length 3 geometric progressions, right? So example here, I'll just consider simple example here. N equals 5, k equals 2, and we have some array, I guess, right? So this one, I'll consider first input here, 1 1 2 2 4, right? So the output will be 4 for this one. I'll just we are not considering the approach yet. I'll just give the answer directly here. So this one answer or the result will be, I'll just give here result, this one will be 4. So this is fine. So this is nothing but the n, this is nothing but the k. Array we have here is 1 1 1 2 2 4, and the result that we need to get here is 4, right? So this is just about the input output pattern. So we'll consider that one later as well. So let me read the question loudly. Just listen to this again. So we have been given array A. So we know this one. We have been given array A of size n and the ratio k. We have to count the subsequences I less than j and j less than L, so that A of j, A of j is equal to A of I into k, and A of L equal to A of j into k. So this one and this part as well, right? So these two things, this is fine. So this one also we have considered. Now we can consider the triples that need not to be contagious again. So just keep this in mind while solving the problem or while writing the code. This matters a lot actually. Triples need not to be contagious. They have not stressed that it has to be contagious at any cost. They have said that triples need not to be contagious. Only indices must be strictly increasing, right? So this is fine. Values can be negative or large, right? So k greater than or equal to 1. When I say values can be negative or large, k can be greater than or k has to be greater than or equal to 1. And what we need to do in simple terms, we have to output the total number of length 3 geometric progressions, right? So here again we have to output length 3 GP or the geometric progressions, right? So I have shown the input output as well along with the examples, right? So let me come here to the input output. So again, So here this is nothing but n, and this is nothing but the k, right? N we have been given 5, so we have 5 integers here, 1 1 2 to 4. So the output that we need to get here is 4, right? So here again, so this is n and this is k, and n we have been given 3, and we have 3 integers, and the output that we need to get here is 1. Same goes with this one as well, man, right? I hope the input output part is completely clear. So now I hope the question is completely clear. All we need to do is we have to output the total number of length 3 geometric progressions. That's it, right? So this we have to keep in mind. Now let's do one thing. As we are completely familiar with the question and the input output part, let's discuss the approach followed by the complexities, and then let's write the code, right? So usually these problems are designed to be solved with this one, dynamic programming. It's easier to solve with the dynamic programming, right? So first thing I would like to tell you here is, before hopping into the this one approach part completely, so we will be going with the dynamic programming or the DP to solve this particular problem, right? So first what we will do, we will compress the values to the indices, right? So just to avoid the hash maps, right, and keep the memory low, right? So what we will do, we can solve this problem entirely with a hash map as well, right? So entirely with the hash map. So this is designed to be solved with a DP basically, as well as the hash map or the hash map, right? So I can just completely ignore the DP and solve with the hash map as well. I'm not saying no, but DP, it will be more understandable basically, right? When you solve this one with the DP, I found this one, it's easy to solve with the DP rather than the hash map, right? So one thing, let's first step is we will compress the values to indices just to avoid the hash maps and keep the memory low, and then we will maintain the arrays on the compressed indices, right? So when I say compressed indices, so I'll just go with dp1 of x, and so I'll just be going with dp2 of x here, right? So when I say dp1 of x, so this is hash of singles equivalent to the value x that is seen so far, and dp2 of x is nothing but hash of valid ordered pairs b comma b into k ending at the value x, right? So this is fine, just keep this in mind, man, just at least these two variables. So while explaining the approach, or while explaining the walkthrough by taking certain example, you'll get to know this one better, right? So next what we will do, we will scan from left to right. First what we did, we are compressing the values to the indices just to avoid the hash map, and we are maintaining the DP arrays on the compressed indices. On the compressed indices means here dp1 of x, dp2 of x, right? So this is fine. Now what we will do, we will scan from left to right, right? So we will scan from quite obviously left to right. Just keep this in mind. We will scan from left to right. So when I say we'll be scanning from left to right means, for current x, if k is greater than 1, accordingly with the question, k has to be greater than or equal to 1, right? So for current x, if k is greater than 1 and x modulo k. So this one, just keep this in mind. This part is very important. K is greater than 1 and x modulo k value is equivalent to the 0, and we'll be considering this one, p equals x by k, and we'll be considering p equals x by k. This is fine. Now we'll be adding dp2 of p to answer, as well as we'll be adding dp1 of p to dp2 of x, uh, dp2 of x. So finally we'll increase dp1 of x. See here, so when I say this, first what we will do, as I've said here, this part, so we'll scan from left to right for current x. If k is greater than 1, k has to be greater than or equal to 1 accordingly with the question or the criteria within the question that we discussed earlier, right? So we are scanning from left to right for current x. If k is greater than 1 and x modulo k, this one value, this has to be equivalent to 0, and uh, p will be going with x by k. P we will be going with x by k, right? So this is fine. Now what we will do, we will add dp of 2 here again. So we will be adding dp, sorry, dp2 of p here. So we'll be adding dp2 of p to answer. Also, we will be adding dp1 of p as well, right? So we will be adding dp2 of p to the answer, and we'll be adding dp1 of p to this one, dp2 of p, right? dp2 of uh, dp2 of x basically, right? So not dp2 of p. So let me write here, we will be adding dp1 of p to the dp2 of x. Just remember this one, man. This is fine. All right, so I hope this part is completely clear. Finally, we will increase dp1 of x, right? So we'll be increasing dp1 of x. So that's what we will be doing. So let me go with the example walkthrough. Just keep these things in mind, right? So first we'll be compressing the values to the indices just to avoid the hash map. Then we'll be maintaining the dprs of the compressed values, nothing but dp1 of x and dp2 of x, this thing, right? So just keep this thing in mind. And finally we'll scan from left to right, nothing but for current x, if k has to be greater than or equal to 1. In this case, k has to be greater than 1, and x modulo k, always it has to be equivalent to 0, and p will be going with x by k, right? So now we'll be adding dp2 of p to the answer, and we'll be adding dp1 of p to the dp2 of x, right? Finally we'll increase dp2 of x, this one, right? So I hope this part is completely clear, man. Let me delete this one. Let's discuss the example walkthrough. So I'll just consider the same example, this example, right? So again I'm telling, this is nothing but the n, and this is nothing but the k, and we have the input 1 1, this one double to 4, and we have the output 4 here, right? So first let me do one thing. I'll just delete this one, and let's discuss this one in detail, right? So just give me a second here. So here I have considered the same first example that they have given in the question, right? So this is nothing but n, and this is nothing but k. So this is nothing but n. We have 5 integers here, right? So we the output that we need to get here is quite obviously 4, right? So, and we know that we just have to output the total number of length 3 geometric progressions, right? So let's see the step by step approach here. Just give me a second here. One second. Yeah. So first what we'll do, we'll see the uh, 1. Basically, when I say we'll see 1, so we'll be going with a dp1 of 1. dp1 of 1 is nothing but initially we'll be initializing this one with the value 1, and next one will be this one. So we have input 1 1 here, this one we are considering 1 1 double 1 double 2 4, right? So we'll be going with double 2 4 here. So this one we have initialized this one with 1, and dp of 1, this one will be initializing this one with 2, right? So dp of 1 we are going with 1, again dp1 of 1 will be going with a value 2. So we will be seeing 2. So this one, these two, so we are done with this 1 and 1, we'll be seeing 2. So what we'll do, we'll extend from p equals 1. Quite obviously we'll extend from p equals 1. Now we'll be going with dp of 2 of dp2 of 2 plus dp1 of 1. So accordingly with the approach, if you remember, I said one thing, theoretically, if you remember, right? So we will be adding dp2 of p to answer, and also the next step was we'll be adding dp1 of p to dp2 of x, right? So that's what we'll be doing here. So first we are going with dp2 of p, nothing but here p is nothing but this one we are considering 2. So we are extending from p equals 1. Now as we are extending this one, we will be considering value 2, dp2 of 2, and the second step was we will be adding dp1 of p to dp2 of x, right? dp1 of p to dp2 of x, right? So this one will be dp2 of 2 plus dp1 of 1. So dp2 of 2 will be so the value is 1, right? And dp1 of 1, the value will be considering this one, first one 1, right? So this one 1 plus 1 will be 2. So answer stays 0 itself initially. Answer stays initially 0 itself, and dp1 of 2, now dp1 of 2 becomes 1, right? So answer stays 0 and dp1 of 2 becomes 1. So this is fine. Now let's move on with the next step here. So next we'll be considering 2. So again we'll be going with the same step, man. Here dp2 of 2 equals dp2 of 2 plus this one 2 basically, right? So this one will be dp2 of 2 will be 4. Basically dp2 of 2 here we have got somewhere, yeah, dp2 of 2 the value is 2, right? So 2 2 plus 2 will lead to 4 here, right? And dp1 of 2, this one we know that dp1 of 2 is nothing but 2, right? So dp1 of 2 is nothing but the 2. So this is fine. This is 4 and this is 2. We know this. Now let's see 4. Let's see 4 here. So p equals 2 we have. So we will be adding dp2 of 2. Nothing but the value that we get here is 4. Right. So we'll be adding this one to the answer accordingly with the theory that I explained. So nothing but we will be adding dp1 of p to the dp2 of x. So here p we are considering 2 here. So we will be adding dp2 of 2 to nothing but the value 4. This one dp2 of 2, nothing but 4 to the answer. So answer becomes 4 here in this case, right? So the answer becomes 4 here. Basically the final answer that we got is 4. So we can make pairs here dp2 of 4 plus dp1 of 2, that is nothing but 2, right? So the final answer that we need to represent in the form of output is this one, not this one basically, right? So not the pairs, right? So this one, the output that we got here is 4, right? So the output that we got here is 4, which is equivalent to the output that they have given for the example 1 within the question, right? So our approach works absolutely correct, right? So now as we are completely familiar with the approach, let's do one thing. Let's quickly discuss the complexities part, man, right? So what will be the time complexity and the space complexity here? The time complexity would be big of n log n. So when I say the time complexity is big of n log n, we will be sorting this one for the compression, right? So when I say we'll be sorting this one for the compression, so sorting takes big of n log n again, right? So we'll be sorting this one for the compression. Overall the time complexity would be big of n log n, and we'll be making use of the binary search as well. So we will be performing n binary search, which takes big of logarithmic n for each step, right? So this will be overall sorting plays a dominant factor, and overall time complexity would be big of n log n itself, right? So this is fine. So what will be the space complexity here? The space complexity would be big of n. When I say big of n, we'll be making use of the arrays sorted, uh, one thing from this itself. So we will be sorting, as I've said, in the time complexity, right? So we'll be making use of the sorted array. So we will be going with the unique, and we'll be going with a DPRS as well. So mainly we are making use of the DP for this particular problem, right? So we'll be going with the two DPRS. One is DP1 and another one is DP2. So accordingly with these two arrays itself, we have understood the approach basically, right? So we will be going with the array sorted, unique, and DPRS DP1 DP2 of size less than or equal to both arrays, size less than or equal to n basically. So overall space complexity would lead to big of n here. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of n log n and big of n respectively, right? So as we are completely familiar with the approach, now approach and the complexities, we are good to write the code. Let's start writing the code. So let's start writing the code here. I'll just come to the compiler. So we'll be making use of the fast input and the output, nothing but buffer data and print writer. So I'll just import input output package here, right? So io dot star, and we'll be making use of the different utilities as well. So I'll just go with java dot util dot star. So this is fine. Now let me go with a class main here, right? So this is fine. Now within main, let's go with the main method directly. So I'll just go with main. So let me make use of the input output exception as well. Exception, right? So this is fine. Yeah. Now within the main method, let's do one thing. Let's make use of the buffer data and the print writer, fast input and the fast output. So I'll just go with buffered reader. So this one will be br, it's new, uh, buffered reader. So this one will be new input stream reader. So this one will be system dot in. This is fine. Now let's go with the fast output, nothing but print writer. So this one will be pw equals new print writer. So this one will be system dot out. So I'll just go with system dot out. This is fine. Now let's do one thing. We have to read n and k, right? So if I come here, so we have been given n and k here. We have to read n and k, right? So let me quickly give here string. So I'll just make use of the variable first here. So this one will be buffered radar dot read line. So this is fine. Let me make use of the split keyword here, right? So we need space between n and k. So we are just reading n and k and we need space, right? So that is the reason I'm making use of the split here. So now let's go with the number of elements. A number of elements means I'll just go with n, right? So n and k we have to go with. So I'll just, both are integers, right? So I'll just go with integer. Yeah, this is fine. Integer dot percent. This one will be first of 0, right? So this is for n, and let me consider the same thing for k as well, as it is integer as well. Let me change the variable name, man. That's it. So I'll just go with this one is k, integer dot percent. So instead of the first 0, I'll just go with first of 1. This is nothing but the common ratio, okay, right? So now we have to read the n numbers as strings. So I'll just give here string. This is fine. Let me go with array. This is equal to buffered reader dot read line. This is fine. I'll just go with a split. This is also fine, man. So next step is we'll be going with the long here. So I'll just go with long. This one will be new long of n. So what this represents basically, this is nothing but the original array A, right? So this is array A, this one, man. 1 1 2 to 4, original array A here. So the next part is we will be going with the iteration, nothing but we will be passing this one to the long. So I'll just go with for loop quickly. So this one will be I equals 0, I less than n, and let me increment the I. So this is fine. uh, we are just parsing this one to the long, right? So I'll just make use of long here dot parse. So this one will be long. So this will be iterated value of the array. So this is fine. Yep. Next step is let's go with the coordinate compression. Uh, uh, in simple terms, let's go with the coordinate compression setup. So basically, we are avoiding the hash map for this particular problem. We are going with the DP, right? So let's avoid coordinate compression setup. So instead, let's keep the arrays tight here, right? So we have to go with the sorting as well, right? If you remember accordingly with the approach. So I'll just go with sorted here. This one will be arrays. I'll just make use of copy of here in this sense. So for this particular case, so I'll just go with a comma n. So now let's sort together the unique. So I'll just go with the arrays dot sort. So let me pass the sorted here, this one. This is fine. Now let's do one thing. Let's count the unique values. So let me initialize m to 0, nothing but we are considering the variable m here. So now we have to hold the unique sorted values, right? So I'll be considering the unique this one. What do we call variable? So I'll just go with unique, right? So this is fine. So this one will be new long of n man. This is fine, right? Next, we have to put the first unique. So I'll just go with unique. So this one will be m plus plus, right? So this one, let me assign this one to the sorted of 0. This is fine. Now we are just putting the first unique here. So let me go with a for loop, simple for loop here. This one will be int I equals 1. Let me go with I equals 1, I less than n. So this one will be I plus plus. So we are just collecting the uniques here, and let's skip the duplicates. We don't need the duplicates, right? So let's skip the duplicates. So I'll just write the simple if condition here. So this one will be sorted of I if it is not equal to sorted of this one will be I minus 1. Then let me go with unique. So we are skipping the duplicates, right? For that, I can write on this way, I believe. So this one will be m plus plus equals. Let me assign this one to the sorted of I. I hope this works, man. Let's see. Right, so we are done with this part. Let me come out of the for loop entirely. Now, so as I've said in the approach that we'll be going with a DPRS, right? So we'll be going with a DPRS that is indexed by the compressed value, right? So nothing but in the this one, what do we call? In the approach, we consider DP1 of V, that is nothing but singles of the value V that is seen so far, and DP2 of V, nothing but pairs. Uh, in the question they had given B comma B into K, that is equivalent to the V, nothing but ending at B, right? So let's see the same thing. Let's articulate the same thing in the form of code. So I'll just go with long. First, I'll consider dp1 array. So I'll just give here, let's initialize with new long of, this one has to be m. This is fine. Let me copy the same thing for dp2 as well and make the necessary changes. I'll just change the this one, what do we call, variable name, so from dp1 to dp2. So this is fine. So yep, one. Next, let me initialize answer to 0. This is nothing but the total number of triples. So next, let's do one thing. Let's go with a for loop here. So this one will be for int I equals 0, I less than n. So this one will be I plus plus. So we are just processing left to right. Next, let me go with x equals a of I. This is fine. Um, this is nothing but the current value, and we'll be going with the compressed index for the x, right? So basically, how can I articulate in the form of code? I'll just go with so int. So this one will be index idx. So I'll just go with arrays. So here, before continuing with the code, so we'll be making use of the binary search for this, right? So we'll be making use of the binary search. So let me do one thing. Mm, So just give me a second here. Did I... Yeah, I'll just give you arrays dot, let me go with binary search here. So this one is fine. This one will be unique, comma 0, comma m, comma x. So this is fine, I hope. So this is nothing but the compressed index for x, right? So this is fine. Next step, let's move on with the um, further steps. Let's go with a special case, nothing but when geometric progression is this one, x comma x comma x, right? So we need length 3 basically. So I can just write on this way. We have a condition that k has to be greater than or equivalent to 1. First, we are going with when k is equivalent to 1, right? So the value of k is 1, right? So special case, when the geometric progression is x comma x comma x, because we need length 3, we have to output the length 3 geometric progression, right? So when k is exactly 1, then we have to go with the existing pairs of x that is extended by the current that forms the triples basically. So I can just write it in this way, answer equals answer plus, so this one will be dp2 of index. So this is fine. So next, every previous we have to consider every previous x with current x that forms a new pair. So this is accordingly with the this one, what do we call, approach that we discussed, right? So this one will be dp2 of index equals dp2 of index plus dp1 of index. So this is fine. uh, Next, we have to count the current x as a single, so this one will be dp1 of index. So let me increment this one. So this is fine. So next, what I'll do else, so only numbers divisible by k can be second or third, this one, right? So only numbers that is divisible by k can be second or third in the geometrical progression, right? So or the geometric progression. So I can just write it on this way. If x modulo k, this one we have discussed in the this one, approach already. So if x modulo k has to be equivalent to 0, p equals x by k. So this one I said k has to be greater than or equal to 1. K equals 1 is a special case that we already considered in the line number 34 if you see, right? So we have to consider either k equals 1 or k has to be greater than 1. We have considered the special case. Now else if k greater than 1, then x modulo k has to be 0, and we will be going with a p equals x by k, right? So this one we had discussed, right? So p equals x by k means p is nothing but, in our case when we discussed approach, p is nothing but the previous, right? So that's what the same thing we have to articulate in the form of code, right? So now x modulo k x, this one, if x modulo k equals 0, then first I'll just go with a long p equals x by k, nothing but previous equals x by k here. This is fine. Again, let's go with the compressed index of the previous. So when I say compressed index of the previous, so this one I'll be considering pidx. So this one will be arrays dot, I'll just go with binary search again. So this one will be unique comma 0. Let me pass m as well as the previous as well. This one, right? So we are just going with the compressed index of the previous. So let me go with a simple if condition. So this one will be p index. So if it is greater than or equal to 0, then within the if condition, so this is nothing but we are considering when the previous exists in the array domain, right? So if it exists, then we have to go with the complete triples accordingly with the question, nothing but previous by k, previous and x. Complete triplets I'm speaking of. This will be, when I say complete triplets, it will be previous by k, and this one, second one is previous, and the third one will be x, right? So I can write on this way, answer equals answer plus dp2 of previous index. So this one will be uh, p index. So this is fine. Next step would be we have to form new pairs ending at x, nothing but previous comma x. So this one will be dp2 of index. So equals dp2 of index plus dp1 of previous index one. So this is fine. So yeah, we are done with this part. So next what we will do, let's go with the current x, right? So let's go with the current x that is available now as a single for the future elements, nothing but we have to increment the dp1 of index that we considered, right? So in simple terms I can just write it on this way, dp1 of index. So this one we have to increment. So this is fine, I believe. Right, so now let's do one thing. I'll just come out of this one entirely. We are left with only, this is it for the logical part. We are left with only input output part. Basically, we have to print total number of the triplets as the result in the form of result, right? And we have to flush and close, right? So let's print the total number of triplets. So I'll consider print writer for this one. We have already considered print writer for the output part, right? So I'll just go with the println. So this one we just have to pass the answer. I have considered ans variable, right? So we are just printing the total number of triplets, and then either we can we have to flush or we have to close, right? So I'll just make use of print writer, I think print writer variable pw. You can just make use of flush or close. So usually we make use of flush. For this particular problem I'll just go with the close. Either of them works, right? So this is fine. This is it for the code basically, right? So we are done with the coding part one, right? So before uh, checking the code with the different inputs, let's let me copy paste the signature starter template here. So I'll just go with this one. This is fine. Yep. Now we are done with the coding part, right? So this is fine. Yeah. Now let's do one thing. Uh, yeah. Where is it? 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 Yep. This is fine. Now I'll just come to the problem. So let me copy this one. We have to get the output 4. Let's check. So we have some error here. One error, compilation failed. Illegal start of the expression. What? So this one, let me consider, let me come to line number 33 here. So this is fine. Uh, what we are doing here, we are considering. Oh yeah, so this one has to be, we have considered A here, right? So directly given this one. This one has to be iterated value of the A. So usually this is the problem that happens when we don't make use of this one. What do we call? Flower brackets, right? So this is the problem sometimes. So you completely forget. I completely forgot here to mention the A of I. So this is fine. Let me run this one again. We have some more errors here. So this one is integer dot pass, and this I has to be capital. In the line number 28 and 29 as well. We have to mention I capital here. 28 and 29. So this one, let me go with capital I, and wait, this doesn't. Yeah, this is fine. Here also, let me make this one capital. Let me run this one now. Error has to be gone. Yeah, we are getting the output 4, right? So which is absolutely correct. Let's consider second input. We have to get the output 1. Let's check. Just give me a second here. So we are getting the output 1, right? So let me go with the last input here. So we have to get the output 6. Let's check. Simple. We are getting the output 6, right? So our code works absolutely correct for all the examples that they have mentioned in the question. So let me copy the entire code here. Let me come to the question here. Let me hit the submit button. So let me come to the submission part, paste the code, and let me hit the submit button. I hope this works for all the test cases, man. Let's see. Let's wait for some time. This is fine. So yeah, you can clearly see here in the toast it is showing accepted already, right? So let me come out of this. Here, see the verdict that we got here as accepted. So we have made use of the pure DP here, right? Along with the binary search basically, right? So we have went with the pure DP here, right? So I hope the solution part is completely clear along with the approach as well as the complexities. For now, this is it. Thanks for watching, guys.